Imagine you are floating in near-perfect silence in a room with 7 large windows. Through them, you have the single greatest view in all of human history. You are in the cupola, the domed observation module of the International Space Station. But the most pressing thought in your mind right now isn't about the cosmos, or philosophy, or the beauty of the Earth. The most pressing thought is a much more urgent, much more fundamental, and much more human one. The coffee you had an hour ago has finished its journey through your system, and you really, really need to use the bathroom. And up here, in this billion-dollar high-tech marvel of engineering, that simple, mundane act is one of the most complex, challenging, and carefully designed procedures you will perform all day. You can't just wander down the hall to a quiet room with a simple porcelain fixture. You have to embark on a journey that involves specialized hardware, a precise multi-step checklist, and the quiet but constant hum of a fan that uses airflow to make sure everything goes in the right direction. Tonight, we are going to explore that journey. We are going to take a long, slow, and surprisingly fascinating look at the quiet, hidden, and brilliant engineering of everyday human hygiene in space. From the first clumsy attempts of the Mercury program to the sophisticated recycling systems of the ISS and the challenges of staying clean on a future mission to Mars, this is the story of how we learn to live and stay clean in the most unforgiving environment imaginable. Before we can get to the specifics of brushing your teeth or using the toilet in orbit, we have to start by appreciating the fundamental problems of living in a tiny, sealed metal box far from the comforts of Earth. On our home planet, we are blessed with an open system. We have a vast atmosphere to dissipate odors, a powerful water cycle to clean and replenish our supplies, and a robust gravitational field that ensures that what goes down stays down. In space, you have none of these luxuries. An orbiting spacecraft is a closed system, a tiny, fragile bubble of life, and every single resource must be meticulously managed. The first and most critical challenge is water. Here on Earth, water is so abundant that we are careless with it. We take long showers, we flush toilets with liters of fresh, clean drinking water, we let the tap run. In space, every single drop of water is more precious than gold. Why? Because it is incredibly heavy. And in the world of rocketry, weight is everything. It costs thousands upon thousands of dollars to launch a single kilogram of mass into orbit. Launching all the water a crew of 6 would need for a 6-month mission would be prohibitively expensive and would take up valuable space on cargo rockets. This means that water on the space station must be conserved with extreme prejudice, and more importantly, it must be recycled. This necessity led to the development of one of the most incredible and unglamorous pieces of technology on the ISS, the Water Recovery System, which is part of the larger Environmental Control and Life Support System, or ECLSS. This system is the station's unsung hero. It is a miniature water treatment plant that captures every single bit of moisture it can. It collects the condensation from the station's air, which includes the moisture from the astronauts' own breath and sweat. It collects wastewater from hand washing and oral hygiene, and most famously, it collects the astronauts' urine. All of this wastewater is then sent through a sophisticated series of filters and processors, a journey we will explore in more detail later. The result of this incredible recycling process is water that is, by all scientific measures, purer and cleaner than most of the tap water we drink on Earth. It's a perfect closed loop. The astronauts have a running joke on the station that has become something of a motto for long-duration spaceflight. Today's coffee is tomorrow's coffee. It's a humorous way of acknowledging a profound reality. To survive far from Earth, you must learn to reuse everything. Absolutely nothing can be wasted. This principle of a closed-loop system is the foundation upon which all space hygiene is built. The second fundamental challenge of this closed system is the air you breathe and the germs you carry. In a sealed tin can like the space station, which has a total pressurized volume roughly equivalent to a 6-bedroom house, nothing ever truly goes away. If you were to release a strong smell, like burnt popcorn, that smell wouldn't dissipate into the vastness of the sky. It would linger in the recycled air for days, a constant companion for the entire crew. The same goes for germs. The human body is constantly shedding bacteria and other microorganisms. On Earth, these are dispersed into our vast environment. On the ISS, they are all trapped inside with the crew. This makes the station a unique microbial environment, and surprisingly, some bacteria seem to become more resilient and even more virulent in the microgravity environment. This means that maintaining a clean environment is not just a matter of comfort, it's a matter of crew health and safety. The station's life support system is constantly working to manage this. The air is continuously circulated through a series of complex filters that trap floating particles from dust and crumbs to bacteria and fungi. The system also removes excess carbon dioxide exhaled by the crew and carefully manages the oxygen levels. It's the station's quiet mechanical lung and immune system, constantly scrubbing the air to keep it clean and breathable. So, with these two fundamental challenges in mind, the preciousness of water and the reality of a closed environment, let's begin our tour of a normal day in space, starting, as most days do, with a trip to the bathroom. Imagine waking up after a night spent in a personal sleeping bag tethered to the wall of your small sleeping quarters on the International Space Station. You float out into the main corridor of the station and head for the hygiene station. It's time to wash up and get ready for the day. But how do you do that in a place where water floats? The first thing you have to let go of is the idea of a shower. There are no showers on the International Space Station. The simple, wonderful, earthly pleasure of standing under a stream of hot, flowing water is a luxury that gravity provides and that weightlessness makes almost impossible. If you were to turn on a shower head in 0G, the water wouldn't fall. It would spray out in a chaotic cloud of thousands of individual, wobbly, floating spheres. These water droplets would get absolutely everywhere. They would cling to every surface, get into sensitive electronic equipment, and create a perfect, humid breeding ground for mold and bacteria. It would be a complete disaster. So, the space bath is a much more meticulous and much drier affair. The process relies on a few key items: a small pouch of drinking water, a special no-rinse body soap, and a towel. The astronaut squirts a little bit of water onto their skin. Because of surface tension, the water tends to stick to their body rather than floating away, as long as they are careful. They then apply a small amount of the no-rinse soap, which is designed to clean effectively without needing to be washed off with large amounts of water. They lather up and then simply wipe themselves down with a towel. It's more like a sponge bath than a shower, but it gets the job done. It's a quiet, careful process of managing every single drop of precious, recycled water. It may not be luxurious, but it's a vital daily ritual that helps the astronauts feel clean and refreshed. Washing your hair is a similar challenge. For this, astronauts use a special rinseless shampoo. It's another clever piece of chemistry, a shampoo that cleans the hair and scalp but doesn't need to be rinsed out with water. The astronaut applies a small amount of water to their hair to get it damp, then works the rinseless shampoo in with their fingers. It lathers up a bit, and they use a towel to scrub their hair and scalp. The towel absorbs the shampoo and the dirt, leaving their hair clean. For astronauts with long hair, like Karen Nyberg or Christina Koch, the process is a beautiful and strange 0G ballet, their hair floating around their head in a halo as they work the shampoo in. Now, while there is no shower on the ISS, there was once a shower in space. This is a wonderful, obscure piece of space history. On America's first space station, Skylab, back in the 1970s, the engineers were determined to give the astronauts as many comforts of home as possible. So they designed and built a fully functional space shower. It was an incredible contraption. It consisted of a cylindrical fabric curtain that could be pulled up from the floor to the ceiling, creating a sealed tube around the astronaut. At the top was a push-button shower head, that would spray a limited amount of warm water. The astronaut would have to hold the nozzle right against their skin to keep the water from floating away. At their feet was a powerful vacuum hose. As they showered, they had to constantly use this vacuum cleaner to suck up all the floating droplets of water from the air and from their own bodies. After their shower, they would have to spend another 15 minutes carefully vacuuming every last drop of moisture from the inside of the shower curtain before collapsing it back into the floor. The whole process, from setup to cleanup, could take over an hour. The astronauts who used it said that while it was a wonderful psychological boost to have a real shower, it was so cumbersome and time-consuming that it wasn't really worth the effort. After Skylab, the idea was abandoned, and the simple, efficient towel bath became the standard for all future spaceflight. After washing up, it's time for some other morning rituals. Let's talk about brushing your teeth. This is another simple act that becomes a little more complex in space. Again, the problem is what to do with the waste. You can't just spit a mouthful of foamy toothpaste into a sink. The foam and liquid would fly everywhere. So NASA developed a special edible toothpaste. The astronauts use a regular toothbrush and brush their teeth just as we do on Earth. The toothpaste is designed to be perfectly safe and digestible. So when they are done brushing, they have a choice. They can either spit the foam into a towel or a waste container, or, to conserve water and avoid any mess, they can simply swallow it. Most astronauts opt for the latter. It's a strange but practical solution to a simple problem. It's efficient, it's clean, and it means you never have to worry about rinsing. Shaving presents a similar challenge, but with the added danger of sharp floating objects. A tiny floating whisker from an electric razor could be just as dangerous as a crumb if it gets into an astronaut's eye or a piece of equipment. So most astronauts who shave in space use a regular razor blade and a special shaving cream. The shaving cream is very thick and sticky, designed to trap all the cut hairs so they don't float away. After shaving, the astronaut simply wipes the cream, foam, and trapped whiskers off their face with a towel. Some have also used electric razors that have a built-in vacuum cleaner to suck up the hairs as they are cut. And this brings us to cutting hair and fingernails. Both of these simple grooming tasks have to be done with a vacuum. To get a haircut, an astronaut will use a standard pair of hair clippers, but the clippers are attached to a hose from one of the station's vacuum cleaners. As one astronaut cuts another's hair, the vacuum is held right next to the clippers, sucking up every single stray hair before it has a chance to float away. The same principle applies to cutting fingernails, a task done very carefully over an air vent to ensure every tiny clipping is immediately pulled away and captured by the station's filtration system. Each of these routines is a quiet ballet of careful movements and clever engineering, all designed to contain the small, messy parts of being human in an environment that demands absolute cleanliness and control. Now we arrive at the most complex, most expensive, and most talked about piece of hygiene equipment in all of space exploration. It is a machine that has been the subject of countless jokes, but it is also a marvel of engineering and a critical piece of life support technology. We are going to talk about the space toilet. To truly appreciate the modern space toilet, we have to first journey back to the pioneering days of the Apollo program. For the astronauts who flew to the moon, the system for waste management was, to put it politely, incredibly basic. There was no toilet at all. The system for liquid waste, or urine, was at least somewhat manageable. It involved a condom-like cuff connected to a tube in a bag, or a valve that could vent the liquid directly into space, creating a brief, glittering cloud of frozen crystals. But the system for solid waste was a different matter entirely. It was, essentially, a plastic bag. The official name was the Fecal Containment System, but the astronauts had other, more colorful names for it. The system was a plastic bag that had an adhesive rim.
The astronaut had to stick this bag to their own body to create a seal. The process was difficult, uncomfortable, and required an immense amount of time, skill, and calm concentration to perform correctly in zero gravity. After use, the astronaut had to seal the bag and then knead it with a special packet of germicide to sterilize the contents. As you can imagine, this was by far the most dreaded and most disliked task of the entire Apollo mission. The crews complained about it bitterly, and their very candid and often very funny conversations about it are all captured on the mission voice recordings.
The Apollo system was a lesson in just how important good, functional hygiene equipment is for the morale and well-being of a crew. It was clear that for longer missions on space stations, a much better solution was needed. This led to the development of the first true mechanical toilets for the Skylab and Salyut stations, and later the Space Shuttle. The fundamental principle behind every space toilet since Apollo is a simple and brilliant one. If you can't use water to make things go down, use air. Every space toilet is, in essence, a sophisticated vacuum cleaner. Instead of a water-filled bowl, there is just an opening, and a powerful fan creates a strong airflow that pulls the waste away from the astronaut's body and into a collection system. The early space shuttle toilet was a complex and notoriously finicky machine. It required the astronauts to undergo extensive ground training just to learn how to use it correctly. You had to position yourself perfectly over the small opening to ensure a good seal, and there were a series of switches and levers that had to be operated in the correct sequence. When it worked, it was a huge improvement over the Apollo bags. But it was also prone to breaking down, leading to some very unpleasant and difficult in-flight repairs. The Russian toilets on the Mir space station were known for being a bit simpler and more robust, following the Russian philosophy of rugged, repairable engineering. But they operated on the same basic principle of airflow. And it is this combined experience, the lessons learned from the shuttle and Mir, that led to the design of the advanced toilets we have on the International Space Station today. Let's take a quiet, detailed, and purely scientific look at this marvel of engineering. The modern system is called the Universal Waste Management System, or UWMS. It's a compact, highly efficient toilet designed for long-duration missions.
The UWMS, like its predecessors, uses airflow to collect waste, but it is a much more user-friendly and efficient design. The system has two main parts to separate liquid and solid waste right at the source. For liquid waste, or urine, there is a long, flexible hose with a specially shaped funnel at the end. An astronaut of either gender can use this funnel. When it's time to use it, the astronaut simply turns on a fan which starts the airflow and then uses the hose. The air current pulls the urine into the hose and down into a collection tank. This separation is critical because the urine is the primary source of the precious water that will be recycled by the station's life support system. For solid waste, there is a small, silver can with an opening that is only about the size of a dinner plate. To use it, the astronaut has to position themselves perfectly over the opening to create a good seal. Foot restraints and harnesses help them to stay in the right position in zero gravity. When they are ready, they turn on a powerful fan. This fan starts a strong suction of air that flows into the can, ensuring that all the waste and any odors are pulled away from the body and into the collection system. Inside the can, the solid waste is collected in a special breathable liner bag. After each use, this bag is sealed. The bags are collected in the can, and when the can is full, it is sealed, removed, and stored in a special container. This container is then loaded onto one of the disposable cargo ships to be burned up in the atmosphere. It is a clean, efficient, and very well-engineered system that solves one of the most difficult problems of daily life in space. It's not glamorous, but without it, long-term human presence in orbit would be impossible. It's a quiet hero of the space station.
So, with the morning routine complete, our astronaut is clean, refreshed,
and ready to begin their workday of scientific experiments and station maintenance. But the quiet story of hygiene doesn't end there. It extends beyond the bathroom to the entire environment of their orbital home. Living in a sealed box for 6 months or a year means you have to be a very diligent housekeeper. As we've mentioned, every speck of dust, every stray hair, every crumb from a tortilla will just float around indefinitely until it is either captured by an air filter or vacuumed up. This is why a significant portion of an astronaut's weekend is dedicated to a single, unglamorous task: cleaning the space station. The entire crew participates in a weekly housekeeping session. They get out special, space-rated vacuum cleaners with long hoses and different attachments, and they meticulously clean every surface. They vacuum the walls, the floors, which are also the ceilings, of course, the computer consoles, and especially the air intake vents, where a lot of dust and debris tends to collect. It's a vital task for keeping the station's air clean and its equipment running smoothly. But there's another, more specific cleaning task that is crucial for the long-term health of both the crew and the station itself, and that is the constant battle against microbial life. This brings us to a major, if little-known challenge of long-term spaceflight: the problem of microbial growth. The ISS is a warm, humid, and enclosed environment, which is the perfect breeding ground for bacteria and fungi. We bring these microbes with us from Earth on our skin and in our bodies, and in the strange environment of space, they can thrive in unexpected places. Over the years, astronauts have found patches of mold and bacterial biofilms growing in quiet, hidden corners of the station, often in areas where condensation can build up, like behind equipment panels or near the window seals.
Over millions of years, this process completely reversed their roles. The originally more massive star had so much of its mass stolen that it became the less massive of the two. And the originally smaller star, having feasted on all that fresh hydrogen from its companion, became the more massive star we see today. So the paradox is solved. The evolved-looking star is older, it just lost a lot of weight. And the young-looking star has just had a very big meal. The Algol paradox is a quiet, elegant story of stellar companionship and cosmic cannibalism, and it taught us that stars and binary systems can have very strange and interactive lives. Our final stop in this gallery of celestial contradictions takes us back to the very beginning of the universe. This is a subtle but persistent puzzle known as the cosmological lithium problem. Our theory of the Big Bang is incredibly successful. It makes very precise predictions about the state of the early universe. Specifically, a process called Big Bang nucleosynthesis, which occurred in the first few minutes after the Big Bang, predicts the exact abundance of the first light elements that should have been created. The theory predicts that the early universe should have been about 75% hydrogen, 25% helium, and a tiny, tiny trace amount of lithium. When we look out into the universe, the predictions for hydrogen and helium match what we observe with incredible accuracy. It's one of the great triumphs of the Big Bang model. But there's a problem with the lithium. When we look at the oldest, most metal-poor stars in our galaxy to see what the primordial abundance of elements was, we find that they have only about 1/3 the amount of lithium that the Big Bang theory predicts. There seems to be a significant amount of missing lithium in the universe. This discrepancy is the cosmological lithium problem.
The current system for space laundry is a model of pragmatic simplicity. An astronaut wears their clothes, their shirts, their shorts, their socks, their exercise gear, until they are too dirty to be worn anymore. This might be a few days for a t-shirt or a week for a pair of pants. There are no hard and fast rules. It's mostly up to the individual's personal preference and tolerance. When a piece of clothing is deemed to have reached the end of its useful life, it is not washed. It is placed into a special trash bag. These bags of dirty laundry are then compacted and stored. When one of the disposable cargo ships, like the Russian Progress or the American Cygnus, is full of trash and ready to depart the station,
These bags of laundry are loaded into it along with all the other garbage. The cargo ship then detaches from the station, performs a deorbit burn, and completely burns up upon re-entry into the Earth's atmosphere. So every few months, there is a fiery man-made meteor streaking through the sky that is in part a load of dirty socks and t-shirts. It's the most expensive laundry disposal service in human history. But this throwaway model won't work for a long-duration mission to Mars. You can't possibly pack enough t-shirts and socks for a 3-year journey. So solving the laundry problem is a quiet but critical challenge for future exploration. Scientists are currently working on a number of creative solutions. One idea is to develop advanced antimicrobial fabrics. These are textiles that are woven with materials like silver or copper, which have natural properties that inhibit the growth of odor-causing bacteria. This would allow astronauts to wear their clothes for much, much longer before they need to be cleaned. Other ideas include developing a special microwave laundry machine that would use steam and radiation to sterilize clothes, or a system that uses supercritical carbon dioxide, which can act as a cleaning solvent instead of water.
So we have seen how the simple daily acts of life, from using the toilet to doing the laundry, become immense challenges of engineering and human adaptation in the unique environment of space. We've explored the quiet, hidden systems that make long-term life in orbit possible. Now let's bring our tour to its final chapter. Let's look ahead to the future, to the even greater challenges that await the first human explorers of another world. A mission to Mars will be a journey of almost complete self-sufficiency. As we've discussed, for a 3-year round trip, there will be no resupply ships, no deliveries of fresh water or clean clothes from Earth. The crew must be able to survive and thrive with only the resources they bring with them and the resources they can harvest from their new environment. This means the concept of a closed-loop life support system, which is already so important on the ISS, must be taken to a whole new level of perfection. The first and most critical challenge will be water. While the ISS water recycling system is incredible, reclaiming about 98% of the water on board, a Mars mission will need to do even better. The goal is a system that can achieve close to 100% water recovery. Every single drop from every source, breath, sweat, urine, washing, cooking, plant transpiration, must be captured, purified, and reused. Losing even a small percentage of water on a 1,000-day mission would eventually lead to a critical shortage. So developing even more advanced and reliable water recycling systems is a top priority. But the real game changer for a Mars mission will be the ability to use the water that is already there. We know that Mars has vast quantities of water ice frozen in its soil, especially at the poles and in mid-latitudes. A human base on Mars would be built near one of these ice deposits. Robotic systems would be needed to mine this ice, bring it back to the habitat, and melt it down. This would provide a source of fresh new water to supplement the recycled supply, to be used for drinking, growing food, and even being split into hydrogen and oxygen to create rocket fuel.
But this introduces a whole new hygiene problem, the planetary dust problem revisited. We know that Martian dust is fine, abrasive, and toxic. And if astronauts are regularly going outside to explore, to maintain equipment, or to oversee mining operations, they will be constantly bringing this dust back with them on their spacesuits. The design of the airlock on a Martian habitat is therefore a critical piece of hygiene technology. How do you get an astronaut out of a dusty suit and into the clean habitat without bringing the dust with them? One concept being explored is the suit port. In this design, the spacesuit itself is stored on the outside of the habitat, docked directly to a port in the wall. The astronaut would climb into the suit from behind, through a hatch in the suit's back. The hatch would then be sealed, and the astronaut would detach from the habitat. The suit itself would never have to come inside, dramatically reducing the risk of dust contamination. Other ideas include a kind of astronaut car wash, an airlock chamber that would use blasts of air,
electrostatic charges, or maybe even steam to clean the dust off a spacesuit before the astronaut is allowed to enter the main habitat. Keeping the living space on Mars clean from the planet's own toxic soil will be a constant and vital task. And what about the future of the space bath? For a Mars mission, we will likely need more efficient and psychologically satisfying solutions than just a wet towel. One fascinating concept being researched is the ultrasonic shower. This would be a shower stall that uses very little water. Instead of a stream of water, it would use a fine mist combined with high-frequency sound waves, ultrasound, to vibrate the dirt and oils off an astronaut's skin. It could provide the feeling and effectiveness of a real shower while using only a tiny fraction of the water. These are the kinds of quiet, clever innovations that will be needed to make life on another world not just survivable, but truly sustainable.
And so, our long and quiet journey through the world of astronautical hygiene comes to an end. We've traveled from the simple, uncomfortable realities of the Apollo era's sticky bags to the sophisticated water recycling vacuum toilets of the International Space Station. We've seen how simple acts like brushing your teeth, cutting your hair, or washing your hands become complex ballets of engineering and careful procedure. We've explored the great unsolved problem of space laundry and the constant, quiet battle against floating dust and invisible microbes. And we've looked ahead to the immense challenges of creating a fully closed-loop, self-sustaining system for the first human explorers of Mars. It might seem like a strange and perhaps unglamorous topic to spend so much time on. We are often so focused on the grand, heroic aspects of space exploration, the powerful rockets, the distant worlds, the breathtaking discoveries, that we forget about the small, mundane human realities. But I think there is a profound beauty in studying these quiet, domestic details. The immense effort, the incredible ingenuity, and the billions of dollars that have been dedicated to solving these seemingly simple problems reveals a deep and fundamental truth about what it means to be human. It shows us that we have a profound, innate need for cleanliness, for comfort, and for the simple dignity of a normal daily routine. These things are not luxuries, they are essential for our psychological well-being. The story of space hygiene isn't just about toilets and towels, it's about making a sterile, unforgiving machine feel like a human home. It's the quiet, unseen, and often unappreciated work that makes long-term life among the stars possible. Contemplating the incredible cleverness it took to solve the simple problem of how to wash your hair in a place with no gravity can be just as awe-inspiring in its own way as contemplating a distant galaxy. It is a testament to our adaptability, our resilience, and our endless quest to bring a little piece of our familiar world with us wherever we may go.
Let's drift back for a moment to the challenge of washing your hair in space. We mentioned the rinseless shampoo, but let's quietly consider the full sensory experience. An astronaut with long hair, like Christina Koch or Megan MacArthur, has to perform a task that is a beautiful example of fluid dynamics in microgravity. They start by carefully squirting a small amount of water from a pouch onto their scalp. The water doesn't run, it forms a cohesive, wobbly blob that clings to their hair due to surface tension. They have to gently work this blob around their head to get all their hair damp. Then comes the no-rinse shampoo. They work it through their hair, creating a small amount of lather. Then comes the most important part, the towel. They use a dry, absorbent towel to vigorously scrub their hair and scalp. This isn't just about drying, it's about cleaning. The towel wicks away not just the moisture, but also the shampoo and the dirt and oils that the shampoo has lifted. After a few minutes of this, their hair is clean and damp. They then have to let it air dry. And in zero gravity, with no down for it to hang, their hair will float freely around their head in a beautiful, almost magical halo, slowly drying in the filtered air of the station. It's a routine that turns a simple daily act into a quiet performance of both science and art. Now, let's think more about the teeth. We mentioned the edible toothpaste. This was a specific invention for the space program, designed by a dentist who worked with NASA. The brand name was NASADent. It was formulated to be safe to swallow, so astronauts wouldn't have to spit. Spitting in zero-G is a terrible idea. The force would send a foamy, messy glob of saliva and toothpaste flying across the cabin. So swallowing was the only practical solution. But what about dental hygiene in general?
On Earth, we can visit a dentist regularly. In space, that's not an option. A simple toothache or a cavity could become a major medical issue on a long mission. Because of this, dental health is a huge priority for astronauts before they ever leave the planet. They have to undergo a thorough dental examination and have any potential issues, like old fillings or wisdom teeth, taken care of long before their flight. Their oral health has to be perfect. While in space, they maintain a very rigorous oral hygiene routine, brushing after every meal if possible. But scientists have also studied how the space environment itself affects teeth. Some research suggests that the changes in saliva production and the slightly different diet in space could alter the microbial environment of the mouth, potentially increasing the risk of cavities. And the bone loss that affects the jaw could, in theory, lead to teeth becoming loose over very long-duration missions, like a trip to Mars. It's another one of those quiet, subtle medical challenges that we need to fully understand before we venture farther from home. Now let's revisit that most complex of hygiene systems, the space toilet. The modern universal waste management system on the ISS is the result of decades of trial and, most certainly, a lot of error. It's a marvel of user-centered design, at least compared to what came before. The engineers spent a lot of time talking to astronauts, especially female astronauts, to design the funnels and the seat in a way that was more comfortable, more efficient, and easier to use for a wider range of body types. Creating a good seal with the system is paramount, as you can imagine, to ensure that the airflow does its job and nothing escapes into the cabin. It's a task that requires a surprising amount of skill and practice to get right.
The skill required to use the space toilet properly is one of the first and most important things a new astronaut learns in their ground training. NASA has a special positional trainer toilet, a mock-up of the real thing, complete with a camera inside the bowl that allows the trainee to see on a monitor if they are correctly aligned with the small opening. It can be an awkward and slightly embarrassing part of training, but it is absolutely essential. A mistaken alignment in zero gravity can lead to a messy and hazardous situation that no one wants to deal with. Let's talk more about what happens to the waste once it's collected. The solid waste, as we said, is collected in individual liner bags within a larger can. When this can is full, usually after about 10 days for a crew of 3, it is sealed and a new one is installed. These sealed cans are then stored and eventually loaded onto a departing cargo ship for disposal. The liquid waste, the urine, goes on a much more interesting journey. It is the beginning of its transformation back into drinking water. The collected urine is first pre-treated with a chemical solution that contains chromium trioxide and other chemicals. This is a strong acid that prevents any microbial growth in the urine and also stops the ammonia from breaking down and causing blockages in the system. This pre-treated urine is then pumped into the urine processor assembly, or UPA. This is the heart of the water recycling system. The UPA is essentially a low-pressure vacuum distillation unit. It gently heats the urine in a spinning centrifuge, and the vacuum, the water turns into vapor at a much lower temperature than it would on Earth. The centrifuge separates the heavier briny materials, the salts, minerals, and other contaminants from the light, pure water vapor. This leftover brine is collected and disposed of, while the water vapor moves on to the next stage of its journey to become pure, clean water once again. It's a quiet, hidden, and continuous cycle, the mechanical heartbeat of the station's life support.
The water processor assembly, or WPA, is where the final purification happens. It takes the water vapor produced by the urine distillation, as well as all the other wastewater collected from the station,
the condensation from the air, water from hand washing, leftover toothpaste foam, and puts it through a multi-stage filtration process. It passes through a series of increasingly fine filters that remove any particulate matter. Then it goes through a multi-filtration bed, which contains layers of different absorbent materials that can remove dissolved chemical contaminants. After this, the water is sent to a catalytic reactor, a high-temperature unit that is designed to break down any remaining complex organic molecules into their simple, harmless components. Finally, an iodine solution is added to the water to prevent any future microbial growth while it's in storage. The result of this exhaustive process is water that is continuously monitored for purity and is, by every measurable standard, cleaner than almost any tap water on Earth. This system, for all its brilliance, has had its share of problems. The urine distillation unit, in particular, has broken down several times over the years, forcing the astronauts to become high-tech plumbers. They had to perform complex, multi-hour spacewalks to replace pumps and troubleshoot clogged lines. It's a testament to the fact that even the most advanced technology requires constant human care and attention to keep running. The ability to fix your own toilet is a very valuable skill for an astronaut. The ECLS system as a whole is one of the most complex and most vital pieces of hardware on the station. It is a quiet, humming testament to the immense challenge of creating a tiny, self-sustaining bubble of Earth in the middle of the void. So, with our astronauts' morning routine complete, let's think about the clothes they put on. This brings us back to that quiet, persistent, and surprisingly difficult problem of space laundry. We know that there are no washing machines on the ISS. The throwaway clothing model is the only one we currently have. Let's explore that in a little more detail. How much clothing does an astronaut actually need for a 6-month mission? The answer is a lot. NASA typically allocates a certain amount of clothing mass for each crew member. This includes a number of t-shirts, shorts, work pants, socks, and underwear. Exercise clothing is particularly important, as astronauts have to work out for 2 hours a day to protect their bones and muscles. This, of course, creates a lot of sweaty laundry. An astronaut might wear a t-shirt for 2 or 3 days before changing it. A pair of pants or shorts might be worn for a week or more. Socks and underwear are usually changed more frequently, perhaps every day or every other day. But there is no hard and fast rule. It's mostly up to the individual astronaut's personal comfort and the tolerance of their crewmates. The clothing is designed to be comfortable and functional. Much of the exercise gear is treated with special antimicrobial coatings to help reduce the growth of odor-causing bacteria, allowing it to be worn for longer. But eventually, every piece of clothing reaches the end of its life. It is then carefully folded or rolled and placed into a special trash bag. This isn't just about being tidy. Compressing the trash is very important to save space. These bags of dirty laundry, along with all the other station garbage, are then stored in a designated module until a cargo ship arrives. It's a strange thought, a closet full of clothes that you know you will never wash, that you will only wear once to the point of being done, and then discard to become a man-made meteor.
The reason a space laundromat is so difficult to engineer is worth dwelling on. We mentioned the problem of water and the mechanics of a spinning drum, but let's think about the soap or detergent. On Earth, modern washing machines are very efficient, but they still leave a small amount of chemical residue in the clothes. In a closed system like the space station, you wouldn't want those chemicals off-gassing into the air you breathe. You would need a completely new kind of soap that is both effective and perfectly safe for a closed-loop air and water system. And what about drying? A traditional tumble dryer that uses heat and vents hot, moist air would be a disaster, adding too much humidity to the station's atmosphere. A condenser dryer might work, but it would be complex and energy-intensive. This is why scientists are looking at such futuristic solutions. The idea of a microwave laundry machine is a real concept being tested. The idea is that you would place the damp, soapy clothes in a chamber and use microwaves to heat the water molecules directly, boiling the water away while a vacuum system captures the steam for recycling. Another concept is to use supercritical carbon dioxide.
When you put CO2 under high pressure and temperature, it enters a strange state where it behaves like both a liquid and a gas. In this state, it is an excellent solvent and can be used to dissolve and remove dirt and oils from fabric. After the cleaning cycle, you would just release the pressure, the CO2 would turn back into a gas, and your clothes would be instantly dry. These are the kinds of clever, out-of-the-box solutions that will be needed to finally solve the quiet, persistent problem of space laundry for the first explorers of Mars. It's a humble problem, but one that is essential for long-term human happiness and well-being off-world.
Let's now turn our attention from personal laundry to the grander task of keeping the entire house clean. We mentioned that the astronauts dedicate a large part of their Saturday to housekeeping. This isn't just a casual tidy-up, it's a carefully planned and choreographed operation that involves the entire crew. Let's think about the dust again. On Earth, dust is mostly a mixture of outdoor particles like pollen and soil, and indoor particles like fabric fibers and dead skin cells. On the ISS, there is no outdoor dust, so the dust on the station is almost entirely human-made. It is a quiet, floating cloud of us. It's composed of the tiny flakes of skin that we're constantly shedding, the hairs that fall from our heads, and the microscopic fibers that break off our clothing. This dust, because it floats, gets everywhere, and it can be a problem. It can irritate the eyes and lungs, and it can clog the vital air filters that keep the station's life support system running. This is why vacuuming is so important. The crew has several specialized vacuum cleaners on board. These are not like your typical household vacuum. They have to be designed to be quiet so as not to interfere with communications or scientific experiments. And they have to have incredibly good filters to ensure that the fine dust they collect is not just blown back out into the cabin air. The astronauts will spend hours patiently vacuuming every surface, every vent, every nook and cranny of their orbital home. But the cleaning doesn't stop with vacuuming. The second major task is the constant battle against the invisible world of microbes. The ISS is a warm, humid, and enclosed environment, a perfect petri dish for the growth of bacteria and fungi. These microbes are not aliens. They are our own constant companions, the ones we bring with us from Earth on our skin and in our bodies. In the unique environment of the station, they can thrive in unexpected ways.
Over the years, astronauts have found patches of mold and slimy bacterial biofilms growing in quiet, out-of-the-way corners of the station. These often occur in areas where condensation can build up, like behind equipment panels, around the window seals, or near the exercise equipment where there's a lot of sweat. Some of these microbes are harmless, but others could potentially cause illness for a crew whose immune systems are already thought to be slightly suppressed by the effects of spaceflight. And some types of fungi can, over time, actually corrode metal or degrade the rubber seals that are critical for keeping the station airtight. So, a key part of the weekly housekeeping routine is a thorough, station-wide wipe down. The crew uses special disinfectant wipes that contain a solution designed to be effective against a wide range of microorganisms, but also safe for the station's delicate atmosphere and equipment. They methodically clean every surface they can reach: walls, handrails, computer keyboards, the inside of the galley, the bathroom, everything. To keep a close eye on their invisible crewmates, they also conduct regular microbial surveys. This involves taking swabs from different surfaces all around the station, as well as air samples. These samples are then either analyzed in a small lab on the station, or sealed and sent back to Earth for a more detailed genetic analysis. This allows scientists on the ground to keep a constant running census of the microbial population on the station. They can track what is growing where, see how the microbial community changes over time as different crews arrive and depart, and ensure that no potentially dangerous pathogens are gaining a foothold. It's a quiet, invisible, and never-ending battle to keep their home in the stars clean, healthy, and safe. It's a form of cosmic gardening, where the weeds are microscopic.
So,
We have painted a picture of a day of hygiene in orbit, a day of quiet, meticulous, and constant work to maintain a small, clean bubble of Earth in a hostile environment. Now, let's bring our tour to its final chapter. Let's look ahead to the future, to the even greater challenges that await the first human explorers of another world, and the clever ways we might solve them. A mission to Mars, as we have discussed, is a journey of almost complete and total self-sufficiency. It represents the moment humanity truly cuts the umbilical cord to Mother Earth. For a 3-year round trip, there will be no resupply ships bringing fresh water, clean clothes, or spare parts for the toilet. The crew must survive on what they bring and what they can create. This means the concept of a closed-loop life support system, which has been so successfully tested on the ISS, must be taken to a whole new level of perfection and reliability. The challenge of water will be paramount. While the ISS water recycling system is an incredible piece of technology, reclaiming about 98% of the water on board, a Mars mission will need to be even better. The goal for a Mars transit vehicle is a system that can achieve close to 99.9% or as close to 100% water recovery as is physically possible. Every single drop from every single source, breath, sweat, urine, washing, cooking, and even the moisture from solid waste must be captured, purified, and reused. On a 1,000-day mission, even a tiny inefficiency in the recycling process would add up to a critical water shortage by the end of the trip. The life support systems for a Mars mission must not just be efficient, but almost perfectly so, and they must be able to run for years without any major repairs.
But the real game changer for a Mars mission, the thing that makes a long-term base possible, is the ability to use the water that is already there. We know from our robotic probes that Mars has vast quantities of water ice, frozen solid in its soil, particularly at the poles and buried just beneath the surface at mid-latitudes. A human base on Mars would be strategically located near one of these rich ice deposits. The first major task for such a mission, likely even before the humans arrive, would be for robotic systems to begin mining this ice. We can imagine a rugged, semi-autonomous rover, a kind of Martian backhoe, designed to scrape away the top layer of soil and dig up the ice-rich regolith beneath. This material would then be transported to a processing plant. Inside this plant, the soil would be heated up in a sealed oven. The heat would cause the water ice to sublimate, turning directly into water vapor. This water vapor would then be captured, condensed back into a liquid, and stored in large tanks. This in-situ resource utilization, or ISRU, of water would provide a huge reservoir of fresh new water to supplement the recycled supply. This water would be used for drinking, for growing food and a large greenhouse, and most critically, it could be split into its constituent parts, hydrogen and oxygen. The oxygen could be used to create a breathable atmosphere inside the habitat, and the hydrogen and oxygen together could be used to manufacture the rocket fuel needed for the return journey home. The ability to mine water on Mars is the key to unlocking our future there. But this brings us to a whole new hygiene problem, the planetary dust problem, revisited from a new angle. If astronauts are regularly going outside to explore, to maintain their equipment, and to oversee these mining operations, they will be constantly bringing the fine, toxic Martian dust back with them on their spacesuits.
As we've discussed, the dust on Mars is a serious hazard. It's as fine as smoke. It's abrasive like microscopic shards of glass. And it contains toxic chemicals like perchlorates. Keeping this dust out of the clean, pressurized habitat where the astronauts live and breathe will be one of the most critical and relentless daily challenges of a Mars mission. A simple airlock like the one on the ISS might not be enough. Dust particles are so small and so electrostatically charged that they would cling to the suits and inevitably get inside. This has led to the development of some very clever new concepts for how to enter and exit a habitat on another world. One of the most promising is the suit port. Imagine a spacesuit that is not stored inside the habitat, but is permanently docked to the outside wall. The back of the suit would have a hatch that connects directly to a port in the wall of the habitat. To go outside, an astronaut would back into the suit from inside the habitat. They would seal the suit's rear entry hatch and then seal the habitat's port door behind them. They could then simply detach and walk away. The suit itself would never have to come inside, and the dust it collects on the surface would never have a chance to contaminate the interior living space. When they return, they would simply back up to the port, dock their suit, and then climb out of the back of it directly into the clean habitat, leaving the dusty suit outside. It's an elegant solution to a very difficult problem. Other ideas include a kind of astronaut car wash, a multi-stage airlock that would use blasts of air, electrostatic charges, and maybe even a fine mist of water to meticulously clean a spacesuit before an astronaut is allowed to re-enter the main living area. Whatever system we end up using, the daily battle against the pervasive red dust will be a defining feature of life on Mars.
And what about the future of the space bath? For a 3-year mission to Mars, the simple wet towel and no-rinse soap method might start to feel very old. The psychological need for something that feels more like a real shower could become very important. But the problem of water conservation remains paramount. This has led to some fascinating research into ultra-low water showering systems. One of the most promising concepts is the ultrasonic shower. Imagine a shower stall that has no shower head as we know it. Instead, it would use a device that creates a fine, warm mist of water. At the same time, it would use high-frequency sound waves, ultrasound, to vibrate the astronaut's skin. This combination of mist and vibration would be able to dislodge dirt and oils from the skin and hair very effectively, using only a tiny fraction of the water that a normal shower would use. A powerful vacuum and filtration system would be constantly capturing the mist and the dislodged particles, recycling the water in real time. It could provide the sensory experience and cleaning effectiveness of a real shower, while using perhaps less than a liter of water per session. Another idea is to develop new kinds of soaps and cleaning agents that are even more efficient. For example, a soap that changes its properties based on temperature, allowing it to be easily separated from the water in the recycling system. These are the kinds of quiet, clever innovations in the simple domestic sphere of life that will be just as important as the big, powerful rockets for making humanity a multiplanetary species. It's the science of making another world feel like a home. And at the heart of any home is the simple dignity of being clean.
And so, our long, quiet, and surprisingly detailed journey through the world of astronautical hygiene comes to its gentle close. We've traveled from the very dawn of the space age, witnessing the incredibly basic and often unpleasant solutions that the first pioneers had to endure. We saw the evolution from simple tubes of paste to the first freeze-dried meals and the immense relief that came with the simple ability to use a spoon. We have explored the ingenious, complex, and sometimes very loud mechanics of the zero-gravity toilet, a true unsung hero of space exploration. We've toured the galleys and hygiene stations of Skylab, Mir, and the incredible international kitchen of the ISS. We've seen how simple acts like brushing your teeth, cutting your hair, or washing your hands become complex ballets of engineering and careful, meticulous procedure. We've explored the great unsolved problem of space laundry and the constant quiet battle against floating dust and invisible microbial crewmates. And finally, we've looked far into the future, contemplating the immense challenges and the brilliant futuristic solutions that will be needed to keep the first human explorers of Mars safe, healthy, and comfortable on their long, lonely journey. It might seem like a strange and perhaps unglamorous topic to spend so much time on, We are often so focused on the grand, heroic aspects of space exploration, the powerful rockets, the distant worlds, the breathtaking scientific discoveries, that we forget about the small, mundane, but absolutely essential human realities of daily life. But I think there is a profound beauty and a deep fascination to be found in studying these quiet, domestic details. The immense effort, the incredible ingenuity, and the billions of dollars that have been dedicated to solving these seemingly simple problems reveals a fundamental truth about what it means to be human. It shows us that we have a profound, innate need for cleanliness, for comfort, for routine, and for the simple dignity of a normal daily life. These things are not luxuries. They are essential for our long-term psychological and physical well-being. The story of space hygiene isn't just about toilets and towels. It's about the relentless human drive to make a home for ourselves, even in the most inhospitable place imaginable. It's about making a sterile, unforgiving, and dangerous machine feel like a safe, clean, and comfortable human space. It is the quiet, unseen, and often unappreciated work that makes long-term life among the stars possible. Contemplating the incredible cleverness it took to solve the simple problem of how to get a haircut in a place with no gravity can be just as awe-inspiring in its own quiet way as contemplating a distant galaxy. It is a testament to our adaptability, our resilience, and our unending quest to bring a little piece of our familiar, comfortable world with us, wherever we may go in this vast universe. The challenges are immense, but our ingenuity is, I think, even greater.
But let's drift back for a moment to the Apollo era and that infamous fecal containment system, the plastic bag. To truly appreciate the modern space toilet, we need to understand the full, quiet horror of what it replaced. The procedure for using the Apollo bag was laid out in a detailed, multi-step checklist in the astronaut's flight manual. It was a process that could take up to 45 minutes to complete successfully. First, the astronaut had to position the bag with its adhesive rim correctly on their body, a task made incredibly difficult by the bulky spacesuit and the zero-gravity environment. A mistake in placement could lead to a messy and deeply unpleasant situation. After use, the procedure became even more complex. The astronaut had to seal the bag, and then inside the sealed bag was a smaller pouch containing a blue germicide. They had to break this inner pouch without breaking the outer bag, and then carefully knead the bag for several minutes to ensure the germicide mixed with the contents to sterilize them and prevent any gas buildup. The Apollo 10 mission, the dress rehearsal for the first landing, had a particularly memorable and humorous incident with this system, all captured on the mission's voice recorders. The crew can be heard suddenly reacting with alarm as a piece of waste escapes its bag and begins a slow, weightless journey through the command module. The transcript captures their frantic and darkly funny exchange. "Give me a napkin, quick," one astronaut says. "There's a turd floating through the air." Another replies, "I didn't do it. It ain't one of mine." It's a moment of high-tech slapstick that perfectly encapsulates the unglamorous reality of early spaceflight. It's no wonder that improving the system was a top priority for future station designers. The comfort and dignity of the crew depended on it.
Let's also spend more time with the concept of the closed-loop system, because it is the single most important principle in all of long-duration spaceflight. On Earth, we live in what feels like an open system. We use water, and it flows away. We breathe out air, and it dissipates into the atmosphere. We throw away trash, and it is taken somewhere else. But of course, Earth itself is a closed system, a giant biological spacecraft. It's just so large that its recycling processes, the water cycle, the carbon cycle, the nitrogen cycle, are mostly invisible to us. A space station is just a miniature mechanical version of Earth, and because it is so small, its crew is intimately aware of every part of the loop. Nothing is wasted.
The ECLSS system on the ISS is a beautiful example of this. We talked about how it recycles water from urine and humidity, but it also manages the air. The carbon dioxide that the astronauts exhale is captured by a special system called the Carbon Dioxide Removal Assembly, or CDRA. This system uses beds of a porous, clay-like material called zeolite to trap the CO2 molecules from the cabin air. Once a bed is saturated, it is exposed to the vacuum of space, which purges the CO2, and the bed can be used again. But even this captured CO2 is not wasted. A newer system, called the Sabatier system, takes this captured carbon dioxide and combines it with hydrogen that is generated as a byproduct from the station's oxygen generator. This chemical reaction produces two things: water, which goes back into the water recycling system, and methane gas, which is currently vented into space, but could one day be used as a propellant. It is a nearly perfect loop, a quiet, humming mechanical ecosystem that turns waste products back into the very things needed to sustain life.
Let's talk a little more about the sounds and smells of life in space from a hygiene perspective. As we said, the station has a constant background hum. But the smells are something astronauts often comment on. The station doesn't smell bad, but it has a very distinct and unforgettable odor. It's often described as a combination of smells, a unique space station scent. There is a faint, metallic, almost ozone-like smell that lingers in the air, especially near the airlocks after a spacewalk. This is the smell of space we talked about before. There is also the smell of the equipment itself, the scent of warm electronics and sterilized materials. And then there are the human smells. The faint odor of stale sweat from the exercise equipment, the scent of the various international foods being warmed up for dinner, and the slightly antiseptic smell of the cleaning wipes used for housekeeping. All of these smells blend together in the recycled air to create a unique perfume that, for any long-duration astronaut, becomes the smell of home. Odor control is a serious business. The air filtration system uses activated charcoal beds to absorb many of the volatile organic compounds that cause odors. And the astronauts are, of course, very mindful of their own personal hygiene, knowing that they are sharing a very small space. Even so, when the hatch to a newly arrived spacecraft from Earth is opened, like a SpaceX Dragon or a Soyuz, the crew is often hit with a wave of familiar earthly smells. The scent of the fresh produce, the smell of the new equipment, even just the smell of normal, unrecycled air from Earth can be a powerful and emotional sensory experience. A brief reminder of the rich and varied world of scents they have left behind. It's another quiet way that the reality of a closed system makes one appreciate the open system of our home planet.
Let's now return to the future and the immense challenges of a human mission to Mars. We talked about the big picture problems, but let's quietly consider some of the smaller, more personal hygiene challenges that the first Martian explorers will face. Think about skincare. On Earth, our skin is protected from the sun's harshest radiation by our atmosphere. On Mars, the atmosphere is thin and provides very little protection. An astronaut on a spacewalk on the Martian surface would be exposed to significant levels of solar and cosmic radiation. Even inside the habitat, the radiation levels will be much higher than on Earth. We know that radiation can damage skin cells and accelerate the aging process. So, the first Martians will need a very robust skincare routine, likely involving specialized lotions and sunscreens designed to protect and repair the skin in a high radiation environment. And what about mental hygiene? We've talked about the psychological stress of isolation, but the very environment of the habitat will be a challenge. Humans have evolved to have a deep psychological connection to nature. The color green, the sight of a tree, the feeling of a breeze. These things have a calming effect on us. A Mars habitat will be, by necessity, a sterile, mechanical, and artificial environment.
To combat this, mission planners are thinking about how to design the interior of the habitat to be as psychologically comforting as possible. This includes things like using dynamic LED lighting that can change its color and intensity to mimic the time of day on Earth, from a warm sunrise to a cool twilight. It includes piping in artificial nature sounds like birdsong or the sound of a flowing river. And it includes those small but vital space gardens. The ability to see and touch a living green plant will be an incredibly important piece of psychological hygiene for the first people living on a dead red world.
Let's also think more deeply about the concept of waste on a Mars mission. On the ISS, as we said, solid waste, from food packaging to dirty laundry to the contents of the toilet, is simply loaded onto a cargo ship and burned up in Earth's atmosphere. On Mars, there is no away to throw things. Every single scrap of waste is a resource that must be managed, recycled, or stored safely for the entire duration of the mission. This has led to the concept of closing the loop on solid waste as well. Human solid waste, for example, is rich in organic matter and valuable nutrients like phosphorus and nitrogen. In a Martian greenhouse, this waste would not be discarded. It would be sent to a bioreactor, a machine that would safely break it down, sterilize it, and process it into a nutrient-rich fertilizer that could be fed directly back to the plants. It's the ultimate form of recycling, turning a waste product into the very food the astronauts will eat. The same principle applies to everything else. All food packaging would need to be designed to be either recyclable or combustible. Perhaps the plastic pouches could be melted down and reformed into new tools or spare parts using a 3D printer. Or perhaps they could be incinerated in a small, efficient system to generate a little extra heat or energy. Every single item brought from Earth has to be thought of not as a disposable product, but as a permanent part of a tiny, closed ecosystem. The first Martians will have to be the most efficient and dedicated recyclers in human history out of pure necessity. It's a quiet lesson in sustainability that we are still trying to learn on our own, much larger, but still finite, home planet.
Now, let's take a final, quiet look at a very human aspect of hygiene that we haven't touched on: personal space and privacy. In the vast emptiness of space, the one thing astronauts have the least of is privacy. On the ISS, crew members have their own small private sleeping quarters, which are about the size of a phone booth. This small space is their only personal territory on the entire station. It's where they can make private video calls to their families, read a book, or just have a quiet moment to themselves. But all other aspects of life are communal. The galley is communal, the science labs are communal, and of course, the bathroom is communal. There are only 2 toilets on the entire US segment of the station and 1 on the Russian segment for a crew of up to 7 people. This requires a level of coordination and social grace that is hard to imagine. The walls on the station are also not very thick. Sound travels easily. This means that a private conversation is almost impossible. Astronauts often wear headsets to talk to each other or to mission control to maintain some level of privacy. This constant proximity to your crewmates for 6 months or a year is one of the most challenging psychological aspects of life in orbit. For a mission to Mars, this will be even more extreme. The crew will be in an even smaller vehicle for the long transit, and then in a small habitat on the surface for 3 years. The design of that habitat, with a careful consideration for providing private spaces for each crew member, will be absolutely critical for the mental health and well-being of the crew. In the vastness of space, a small room of one's own becomes one of the most precious commodities there is. It's a quiet, human need that is just as important as air or water.
Let's return for a moment to the history of hygiene and visit a strange footnote from the Russian space program. We've talked about their practical canned food, But they also had a different approach to personal hygiene in the early days. During some of the long-duration Solute missions, cosmonauts had access to a special wet wipe suit. It was a one-piece garment lined with damp, soapy cloths. A cosmonaut could zip themselves into this suit and use the interior lining to give themselves a full-body sponge bath. It was a strange but clever solution to the problem of washing without creating floating water droplets. Another interesting detail is the challenge of doing dishes. On Earth, we just put a plate under the faucet. In space, it's not so simple. For the most part, there are no dishes to do. Astronauts eat directly from the pouches and cans, which are then disposed of. But what about the spoons and forks? On the ISS, the crew has a supply of metal utensils. After each meal, they simply clean them using a disinfectant wet wipe, just as they would clean a countertop. It's a simple, waterless solution. These small, clever adaptations are everywhere you look in the history of spaceflight. Each one is a quiet testament to the thousands of hours of thought that have gone into solving the simple, mundane problems of daily life. It's a world of ingenious workarounds, from edible toothpaste to Velcro patches on the walls for holding on to tools, all designed to make an unnatural environment just a little more manageable, a little more human. Every aspect of a normal day has been re-examined and re-engineered for the strange new reality of a world without weight.
As we think about the future on Mars, another hygiene challenge emerges: protecting Mars from us. When we send robotic rovers to Mars, they go through an incredibly rigorous sterilization process. We bake them, clean them with powerful chemicals, and assemble them in ultra-clean rooms to ensure that we don't accidentally contaminate the Martian surface with Earth microbes. This is a principle called planetary protection. We want to be sure that if we ever do find life on Mars, it's actually Martian life, and not just bacteria that hitched a ride from our own planet. But how do you do that when you send humans? Humans are walking, breathing clouds of microbes. We can't be sterilized. Our bodies contain trillions of microorganisms that are essential for our own health. So, the first human mission to Mars will inevitably contaminate the planet with Earth life. This is a deep and complex ethical and scientific challenge that scientists are still debating. The first human habitats on Mars will have to be strictly contained biological bubbles, and the spacesuits astronauts wear will have to be designed not just to protect the astronaut from Mars, but to protect Mars from the astronaut. The procedures for leaving and re-entering the habitat will have to be incredibly strict to minimize the amount of microbial contamination we release into the Martian environment. It's a profound responsibility. We must be careful to be good guests as we explore these new worlds, ensuring that our search for alien life doesn't end with us accidentally planting our own. It's a quiet, ethical consideration that adds another layer of complexity to our future in space. Let's conclude our deep dive with a final look at the psychology of cleanliness. The act of cleaning, both our bodies and our environment, is more than just a way to stay healthy. It is a powerful psychological ritual. On Earth, we often use the act of cleaning to create a sense of order and control in our lives. A clean room feels like a calm mind. A hot shower can feel like washing away the stresses of the day. For an astronaut in a high-stress, high-stakes environment, these rituals become even more important. The simple, methodical process of wiping down the walls of the station on a Saturday morning, or carefully preparing your hygiene kit for the day, can be a form of meditation. It's a small, predictable, and controllable task in a life that is otherwise filled with complex experiments and the inherent risks of spaceflight. It's a way to create a sense of normalcy and home. The feedback from astronauts is consistent on this point. Having access to good hygiene facilities, having clean clothes to wear, and having a clean environment to live in are all critically important for long-term morale and crew cohesion. It's about dignity. It's about feeling human. When we plan for future missions to the Moon and Mars, the engineering of the toilets, the showers, and the laundry systems
are not just secondary concerns. They are just as important as the design of the rockets and the life support systems. They are part of the human support system. They are what will allow us to not just survive in these distant places, but to truly live there.
Let's continue with a simple but serious question. What happens if an astronaut gets a simple cut in space? On Earth, you would clean the wound, perhaps put on a bandage, and let gravity help keep the blood flowing downwards. In zero gravity, it's a different story. A cut would produce blood that doesn't drip, but instead forms a floating, cohesive sphere due to surface tension. This floating blob of blood could easily contaminate surfaces or get into equipment. So a key part of any space first aid kit is not just bandages, but highly absorbent materials and special procedures for containing any bleeding immediately at the source. And how do you clean a wound? You can't just run it under a tap. Astronauts use special antiseptic wipes and saline solutions in squeeze bottles, carefully applying the liquid and immediately wiping it away with gauze to ensure no droplets escape. Giving an injection is another challenge. Any air bubble accidentally injected into a vein could be much more dangerous in microgravity, where it might not travel as predictably through the circulatory system. The procedures have to be meticulous. The ISS is equipped with a comprehensive set of medical supplies, part of a system called the Crew Healthcare System, or CHCS. This includes several different kits. There are first aid kits for minor injuries, packed with bandages, antiseptics, and wound dressings. There's a more advanced medical kit with diagnostic tools like a portable ultrasound machine, a defibrillator, and even dental tools for temporary fillings. And there is a pharmacy kit, stocked with a wide range of medications, from simple painkillers and allergy tablets to powerful antibiotics and emergency drugs. The crew includes at least 2 crew medical officers, astronauts who have received extra paramedic devil medical training to handle emergencies. They can perform minor procedures like giving stitches or providing injections, all while consulting with flight surgeons on the ground via a private medical channel.
But this brings us to another quiet and persistent medical challenge: the stability of those medicines. As we touched on briefly in another story, a long-duration mission to Mars faces the problem of drug degradation. The constant low-level exposure to galactic cosmic radiation can slowly break down the complex molecules that make many medications work. A study on the ISS found that after about a year in orbit, some medications had lost a significant amount of their potency. An aspirin might be less effective. An antibiotic might not be strong enough to fight off a serious infection. This is a huge hurdle for a 3-year Mars mission. You need your pharmacy to be reliable for the entire journey. Scientists are working on several solutions. One is to develop new, more radiation-resistant formulations of essential drugs. Another is to create better radiation-proof packaging for the medical kits. And a more futuristic idea is the concept of an on-demand pharmacy. Instead of bringing all the finished drugs, you would bring a set of stable chemical precursors and a small automated chemical synthesizer. If an astronaut needed a specific medication, the flight surgeon could, in theory, print a fresh dose of the drug on demand, ensuring it is at full potency. This also ties into the challenge of diagnosis. Without a full hospital lab, how do you know what's wrong with a sick astronaut? The portable ultrasound on the ISS is a key tool, and astronauts are trained to perform scans on each other with guidance from doctors on the ground. Researchers are also developing lab-on-a-chip devices, tiny portable kits that could perform complex blood tests or diagnose illnesses from a single drop of saliva. All of this technology is designed to create a self-sufficient medical system, allowing a small crew to be their own doctors and their own pharmacists, millions of miles away from the nearest hospital. Now, let's drift from the health of the body to the health of the mind. Let's take a deeper dive into the quiet art of psychological hygiene. As we've discussed, living in a small, isolated, and unchanging environment for months on end is an immense mental challenge. NASA and other space agencies put a huge amount of effort into maintaining the psychological well-being of the crew. One of the most important tools is communication. While the crew can't just pick up a phone and call anyone, they have regularly scheduled private video conferences with their families back on Earth. These IP phone calls are a vital connection to home, a chance to see loved ones, share stories, and maintain those crucial family bonds. The astronauts have a private laptop and a headset, and they can have these calls in their own personal crew quarters, giving them a rare moment of true privacy. Entertainment is another key part of mental hygiene. The ISS has a large digital library of movies, music, and books that the crew can access on their laptops during their off-duty time. It's not uncommon for the entire crew to gather on a Saturday night with some snacks to have a movie night, watching a film together as it floats on a laptop screen tethered to the wall. These moments of shared recreation are essential for team bonding and for providing a sense of normalcy. And then there is the window. The cupola module, with its 7 large windows offering a panoramic view of the Earth, is more than just an observation deck. It is the station's psychological heart. Astronauts consistently report that spending time in the cupola, just quietly watching the world go by, is one of the most calming and restorative things they can do. It's a form of meditation, a way to gain perspective and to reconnect with the beauty of their home planet. Maintaining the cleanliness of these windows is a surprisingly important housekeeping task to ensure that this precious view is never obscured.
Let's now turn our attention back to the physical space and talk more about food safety and galley hygiene. In an environment where everyone's immune system might be slightly compromised, preventing foodborne illness is absolutely critical. The system used to ensure the safety of space food is a revolutionary one that has had a massive impact on the food industry right here on Earth. It's called HACCP, which stands for Hazard Analysis and Critical Control Points. This system was pioneered by NASA in partnership with the Pillsbury Company during the Apollo program. They needed a way to be 100% certain that the food sent to the moon was free from any harmful bacteria or toxins. The traditional method of food safety, which involved testing a few random samples from a large batch, wasn't good enough. You could test 10 samples and find them all to be fine, but the 11th one, the one you didn't test, could be the one that gets an astronaut sick. So they developed a new system. HACCP doesn't focus on testing the final product. It focuses on proactively identifying and controlling every single potential hazard at every single step of the food production process. From the raw ingredients to the cooking process, the packaging and the storage, every critical control point is monitored and controlled to prevent contamination before it can ever happen. This system was so successful that it was later adopted by the entire food industry. The reason the food you buy in a grocery store today is so safe is, in large part, thanks to the work done to ensure the safety of the food eaten by the Apollo astronauts. On the station itself, galley hygiene is a top priority. Before preparing a meal, an astronaut will clean the galley surfaces with disinfectant wipes. All food packages are carefully opened to prevent any spillage. And speaking of spills, what happens if a glob of beef stew or some sticky orange juice escapes its pouch?
Containing a spill in zero gravity is a strange and immediate challenge. The liquid doesn't fall to the floor. It becomes a floating, wobbly sphere that will travel through the cabin until it hits a surface. And once it hits a wall or a piece of equipment, its surface tension will cause it to spread out and seep into any available crack or crevice. This is not only messy, but it can be dangerous if the liquid gets into sensitive electronics. So the crew has to act fast. The procedure for cleaning up a spill is to grab a dry, absorbent cloth and gently touch it to the floating glob of liquid. The liquid will be drawn into the cloth by capillary action. They have to do this carefully, without swatting at the glob, which would just break it up into hundreds of smaller, harder-to-catch droplets. It's a quiet, delicate operation. Another small ballet of physics and careful movement. Let's not take a final, deeper dive into the history of these systems.
Let's go back to the very beginnings of the American and Soviet space programs and explore some of the more obscure hygiene challenges they faced. For example, the Gemini program. The missions were up to 2 weeks long, but the capsule was incredibly small, with no room for a toilet of any kind. The urine collection system was a series of bags and tubes, but the solid waste system was even more basic than the Apollo bags. Cosmonauts on the early Vostok missions faced similar, if not even more rudimentary challenges. For these early space pioneers, hygiene was not about comfort. It was about pure, functional survival in the most minimalist of environments. Their ability to endure these conditions is a testament to their incredible fortitude and focus. Every astronaut and cosmonaut who flies today on the ISS, with its relatively luxurious toilets and dedicated hygiene stations, is building upon the hard-won lessons of these first incredibly rugged pioneers. They proved that humans could survive the harshness of space, paving the way for future generations to learn how to truly live there.
Let's talk more about the concept of planetary protection, because it is a fascinating and deeply philosophical form of hygiene. When we say we want to keep a rover clean to avoid contaminating Mars, what does that really mean? It means protecting Mars from the hardiest life forms on our own planet, microbes. The process of sterilizing a spacecraft like the Perseverance rover is incredibly rigorous. The components are built in clean rooms, which are sterile environments with heavily filtered air, where technicians wear full-body bunny suits to avoid shedding any skin or hair. Any part of the spacecraft that can withstand it is baked at a high temperature for many hours to kill any microbes. Other parts are wiped down with powerful chemical solvents. The final assembly of the rover happens in a giant clean room at the Jet Propulsion Laboratory, and the entire spacecraft is then sealed inside its protective aeroshell for the journey to Mars. The goal is to reduce the bioburden, the number of earthly spores and microbes, to an absolute minimum. But it's impossible to get it to zero. There will always be some incredibly resilient microbes that survive the process, hidden away in the electronics or the rover's interior. These are known as extremophiles, organisms on Earth that can survive in incredible conditions of heat, cold, radiation, and vacuum. So, our planetary protection protocols are also about location. We deliberately choose landing sites for our rovers that are thought to be inhospitable to Earth life. We avoid places where there might be liquid water near the surface, for example. The fear is that we could introduce an invasive species to another world. If we were to land a rover contaminated with Earth bacteria in a potentially habitable spot on Mars, that bacteria could thrive and outcompete any native Martian life that might be there. Our search for life would end up destroying the very thing we were looking for. It is a profound ethical responsibility, a quiet duty to be clean guests as we explore our solar system.
Now, let's explore a quiet, personal aspect of hygiene that we often overlook: the importance of sleep itself. Sleep hygiene is a critical component of astronaut health and performance. In orbit, the normal cues that regulate our sleep cycles are gone. The sun rises and sets 16 times a day. There is no up or down, and the constant hum of the station and the demands of the schedule can make it difficult to unwind. Astronauts have their own private crew quarters, which are essential for good sleep. These are small, soundproofed pods, about the size of a phone booth. Inside, there is a sleeping bag that is tethered to the wall. Astronauts have to zip themselves into the bag so they don't float around and bump into things in the middle of the night. They report that the feeling of being gently held by the sleeping bag is very comforting in a weightless environment. To help regulate their circadian rhythms, the lighting on the space station is carefully controlled. In the morning and during the workday, the lights are a bright, blue-tinted white light, which mimics daylight and promotes alertness. In the evening, before bedtime, the lights throughout the station are shifted to a warmer, dimmer, reddish hue. This signals to the astronauts' bodies that it's time to wind down and prepare for sleep. Many astronauts also use eye masks to block out any stray light,
and earplugs to block out the constant hum of the station machinery. Maintaining a regular sleep schedule is a serious part of the mission. Poor sleep can lead to fatigue, which can lead to mistakes. And in the high-stakes environment of space, a simple mistake can be catastrophic. So the quiet, disciplined act of getting a good night's sleep is a vital part of every astronaut's daily routine. It is the foundation of all other forms of well-being.
As we near the end of our deep, detailed exploration, let's revisit the future of hygiene on a long-duration mission to Mars. We've talked about the big systems, water recycling, laundry, toilets. But what about the small, personal items? You can't pack a 3-year supply of toothpaste or soap or deodorant. These things take up space en masse. This is where the concept of in situ resource utilization extends even to the bathroom cabinet. Future Martian colonists might have to manufacture their own hygiene products. For example, soap can be made through a simple chemical process involving fats, which could be grown in a greenhouse from oilseed crops, and an alkali, which could be derived from Martian minerals. It would be a small-scale but essential chemical plant. Even things like the plastic for a toothbrush could be recycled. A Mars base would have a robust recycling system and a 3D printer. Old, broken equipment, food packaging, and even old toothbrushes could be melted down into a raw filament, which could then be used by the 3D printer to create new, fresh tools and supplies, including new toothbrushes. This is the philosophy of a truly closed-loop system. It's not just about recycling water and air, it's about recycling every single gram of mass. It's a mindset of complete self-sufficiency, born from the harsh reality of living on a world millions of miles away from the nearest factory or supply depot. The first Martians will have to be not just explorers and scientists, but also expert chemists, engineers, and above all, incredibly resourceful recyclers. Every item will have a second, third, and fourth life. It's a quiet, circular economy, a perfect little bubble of sustainability on a distant world. And now, for our final quiet reflection before we conclude. Let's think about the connection between the cleanliness of the body and the clarity of the mind. The psychological importance of these hygiene rituals is something that NASA and other space agencies take very seriously. In every analog mission, where crews are isolated in submarines or Antarctic bases for long periods, psychologists study how personal and group hygiene affects morale. And the results are always the same. When people are in a stressful, confined environment, the ability to maintain a sense of personal cleanliness is directly linked to their mental well-being. A hot meal, a clean set of clothes, the simple feeling of having washed your face at the start of a day, these things are not frivolous. They are anchors of normalcy. They are small, controllable rituals that provide a sense of order and dignity in an otherwise chaotic or monotonous environment. The astronauts on the ISS often talk about this. They speak of the deep psychological satisfaction of a Saturday morning spent cleaning the station together as a crew. It's a shared task that creates a sense of pride in their home. They talk about the simple joy of a fresh-smelling t-shirt or the profound comfort of a warm, wet towel on their face after a grueling 2-hour workout. These are the quiet human moments that get lost in the grand narratives of space exploration. But they are, in many ways, the most important parts of the story. They are the details that transform a high-tech machine from a simple vehicle or laboratory into a human home. And it is this ability to create a home, to maintain a small bubble of human comfort and dignity in the most inhuman of places, that is perhaps our greatest achievement in space so far. It is the foundation upon which all our future explorations will be built.
And so we come to the final, quiet end of our very long and very detailed journey into the world of astronautical hygiene.
We've seen how the most basic, most mundane acts of our daily lives become profound challenges of physics, engineering, and human resilience in the strange world of space. We've explored the ingenious machines that recycle our water and our air, the clever solutions to brushing our teeth and doing our laundry, and the quiet, constant battle against dust and germs. We have traveled from the rudimentary and uncomfortable systems of the first space pioneers to the sophisticated, international, and relatively comfortable home that is the International Space Station. And we have looked ahead to the immense challenges that still await us as we plan to build a self-sustaining human presence on the Moon and on Mars, a future that depends entirely on our ability to perfect these quiet, domestic technologies. The story of space hygiene is a beautiful testament to our adaptability. It shows how we can use our minds to solve the most fundamental problems of our bodies. It's a story that is not about grand adventures, but about the small, daily acts of care and maintenance that make those grand adventures possible. Contemplating the incredible thought that went into designing a toilet that works without gravity or a shower that works without water can be just as awe-inspiring, in its own humble way, as contemplating the stars themselves. So as you settle into your final moments before sleep, let your mind be at peace. Let the quiet hum of the fans and filters of your own home be a gentle reminder of the great humming machine in orbit that is doing the same thing for our astronauts. And in the simple, profound comfort of your own clean, quiet, and safe place to rest, I hope you find a deep and wonderfully restful sleep. Sweet dreams.